So we're going to look at sine and cosine functions. What I want you guys to do, please, is in your calculator type in y equals sine x. And make sure you are in radian mode. Nothing right now. No writing. I just want you to type this in. Y equals sine x and make sure you're in radian mode. That's all I want you to do for right now. Okay? For a lot of this, you don't even have to draw it. You're just going to be paying attention today because I'm introducing you to the graphs because right now you've never seen them. Okay? I want you to change your window to be the same as this window. Now, you're going to go 0. This is 0.5 and this is going to be 1. This is going to be negative 0.5 and this is going to be negative 1. So you're going to go to your window and you're going to do this in your window. Your x minimum in your window is 0 because when you want to draw a graph, you want to make your window be the same as the graph there. Or if you're trying to figure out which graph represents which equation on a test, bless you, you always want to make your window be the same as the graph on the test so you can physically compare them. Because sometimes you'll be like, oh, they're not the same, but actually they are. Your window's just different than the window on the test. So always change your windows to the same window so that your graph will look exactly the same, okay? So your x min is 0, your x max is 2 pi. You're going to type in 2 pi. It'll change it to 6.28, blah, blah, blah. That's fine. That is 2 pi. But you're going to put in 2 pi into your x max. Now, this is the part that people find tricky. They don't know what these ticks are. I don't know what they go up by. So what I always say the easiest thing to do is look for pi and count how many ticks are in between. So this pi, there's pi right here. There's 1, 2, 3, 4, 5, 6 ticks in between. Okay, does that make sense? There's 6 ticks, count them. So there's 1, 2, 3, 4, 5, 6. So what you're going to do is this is broken up into 6 pieces, correct? So it's like dividing by 6 is breaking it up into 6 pieces, correct? So this is pi. This is pi over 6. This would be 2 pi over 6, except it's not going to be written as 2 pi over 6. It's going to be written as pi over 3, right? Because it reduces. It's a really thick marker. Then this would be 3 pi over 6, but 3 pi over 6 reduces to pi over 2, right? When you reduce the fraction. This would be 4 pi over 6, but that would actually reduce to 2 pi over 3. And then this would be 5 pi over 6. This would be 6 pi over 6, but that's just pi. And then we just keep going. This would be 7 pi over 6. This would be 8 pi over 6, but 8 pi over 6 would reduce to 4 pi over 3. This would be 9 pi over 6, but 9 pi over 6 reduces to 3 pi over 2. This would be 10 pi over 6, but it reduces to 5 pi over 3. This would be 11 pi over 6. This would be 12 pi over 6, which is 2 pi, and you can keep going, right? So if you just find the pi and then see how much it breaks up into, you can actually label all of these. So the scale, each little tick is worth pi over 6, we agree? Because that's what the first one is, it's pi over 6. So you're going to go into your x scale and put pi divided by 6, and they'll give you the decimal form of whatever the heck that is. So in your window, you're going to go to your x scale, and you're going to put pi divided by 6. All right? Now your y max is, your y minimum is -1, your y maximum is +1, and each tick is 0.25. Those ones are easier to do. Then press graph. Now you have the exact same window as I have. Okay? That's the sine graph. So, another way to draw the sine graph easily for radian measure is to draw it right off of your unit circle, because the sine values are off your unit circle if you're doing from 0 to 2 pi. Move this back over. Uh-oh. So, if you look at 0, 0 on the unit circle, 0 degrees on the unit circle, what's the sine value? Sine is x or y? Sine is y. So 0 degrees or 0 radians, my sine value is, if you look on the unit circle, if you have one in front of you, it's 0. The y value at 0 is 0. On your calculator, it was 0. It starts here on your calculator, doesn't it? Then I look at the next one. My next I could do pi over 6, I could do pi over 4, I could do pi over 3, and I can plot them. The next one I'm going to choose to pick is 30 degrees, because 30 degrees is, well, 30 degrees, which is pi over 6, is a half. Right? If you go to pi over 6 on the unit circle, sine is a half. The y value is a half. So if I go to pi over 6, I'm at a half. I like picking the values of 0, so you can do that. Then if you do pi over 2 is what? 1. If you look on your unit circle. You can pick all the values in between. You can go pi over 4 to root 2 over 2, turn root 2 over 2 into a decimal and just like kind of guesstimate where it is, right? But pi over 2 is 1. So I'm up here. So far I'm going like this. Then my next half happens at 5 pi over 6. 0.5. 5 pi over 6 is a half. Oops. Then I go down to pi, and at pi it's at -1. Nope, pi is at 0, sorry, because you look at the y value. Comes down here again. And then my next half is -1/2, and it's at 7 pi over 6. Is at -0.5. And then that 3 pi over 2, I'm at -1. At 3 pi over 2, I'm down to -1. And then at 11 pi over 6, I'm back at -0.5. And then at 2 pi, I'm back at 0. So if you use the unit circle, you can draw the basic sine x graph. The basic sine x graph before any transformation. So we're going to be doing transformations on our graphs. So right now, we just have y equals sine x. That's what it looks like. Okay? Now, how could I change this so it's in degrees? What are the two things I would have to change in order to draw this on my calculator in degrees? You'd have to change your mode to degrees, right? You have to change your mode to degrees, and you'd have to change your x scale from 0 to 360 going up 30 degrees. You'd have to change your x scale on your window. And you have to change your x min and your x max on your window, okay? So if you want to do your graph in degree mode, you have to have it in degree mode, the calculator, and your x scale has to be in degrees. If you want to draw this graph in radian mode, you have to have it in radian mode on your calculator, and you have to have your x values in radians. My y values don't change. My y value, my y min, my y max, my y scale is going to stay the same, whether I'm in degrees or radians, because these values are not in degrees or radians, they're just values, okay? Only my x axis is in degrees or in radians. Okay. The period of this graph. A period is how long it takes till it repeats itself. So you're going to write that down. It's the length. Ignore this. It just kind of cuts out with this. It's the period. You're going to write this. The period is the length of the interval of the domain over which a graph repeats itself. This is what you're going to write. Period is the length of the interval of the domain over which a graph repeats itself. So in layman's terms, how far along the x till I repeat myself, till the graph starts doing the exact same thing over and over. Now, these graphs of sine and cosine and tangent are periodic graphs. They keep going. They could go and go forever. The only way they'll stop is if I restrict the domain between like 0 and 2 pi or something like that, right? So often they'll restrict your domain by either graphing it to a restricted domain or they'll tell you they restrict the domain. If not, this graph is going to keep doing the same thing over and over and over, right? Because 0 to 360 will create coterminal angles if I keep going to 720, right? And if I keep going, I'm going to keep getting the exact same circle over and over and over. I'm actually going to keep getting the graph. This graph would go like this, down and then back up and then down and then back up forever that way. And then this is going to go up to 1 and down to -1 and up to 1 and down to -1 forever that way, unless I restrict the domain to something smaller, right? This graph just keeps going infinitely, doing this over and over and over again. So this graph would technically keep doing this. You don't need to draw it, but this is my point. And then it would keep going like this and keep going, correct? So what we need to do for the period of the graph is state how long it takes till it repeats itself. So if I start here, I go up past a max, past a minimum, and then when I get back to that same middle point, it's going to start repeating itself, right? Past a max, past a min, back to that point. Then I'm going to go to a max, then to a min, then back to that point, then to a max, then to a min, and then back to that point. So on a diploma, sometimes what they'll ask you is how many times, or what's the period of the graph, or they'll say how many times does it repeat itself from 0 to whatever. It'll give you a domain and ask how many times it repeats itself. So you have to know the period of the graph, or you have to draw the whole thing. So a sine graph repeats itself every 2 pi. If it is not transformed, if it's not stretched or reflected wouldn't change it, but if it's not stretched or basically stretched. Stretching is what's going to change your graph's period. The B value, the horizontal stretch. Because what does a horizontal stretch do? It takes your X values and it either stretches them wider or it makes them narrower, right? Which is going to cause the graph that normally looks like this to be here or to be further out or to be shorter. So it's that horizontal stretch that's going to affect your period, which we'll talk about soon. But the period of a sine function is 2 pi. Or 360 degrees. It all depends on if the equation is in degrees or if the equation is radians. But it repeats itself every 2 pi or every 360. Okay? So you're learning all these new things about this graph. Amplitude. This is the formula for amplitude. It works for your any sinusoidal or cosine graph, so any sine graph or cosine graph that you're given. If you take the absolute value of the max minus min and divide it by 2, you'll get the amplitude. The amplitude, which you're going to want to write down, is half the difference between the max and the min of a value of a period function. The amplitude is a distance, and distance has to be positive. You can't have negative distance, right? So amplitude is always positive. Amplitude is always positive because it's a distance. It's half the distance between the maximum and the minimum. So you can use this formula all the time, or you can just figure out what it is. How far are we from max to min? From the maximum to the minimum of this graph, how far do I go? So if I start at the minimum, which is down here, I go up 1 and I go up 1 more. So what is that distance? The distance of 2, correct? What's half the distance of 2? 1. So the amplitude for this graph, the sine graph, is 1. We can use the formula to prove it. So if I want to use the formula, it's maximum. These are all y values. So its maximum value is +1, so absolute value of +1 minus the minimum value, which is -1, all divided by 2. The absolute value of 1 minus a -1 is actually 1 plus 1, which is 2. So you get the absolute value of 2 over 2. Absolute value of 2 is just 2, because what does an absolute value do? It just makes it positive, because the absolute value is just the distance from 0. So how far is -2 from 0? 2. How far is 2 from 0? 2. So that's why the absolute value of anything is always positive. So this would be 2 divided by 2, which is 1. So if you use the actual equation, you still get 1. Or you can understand the graph, and the amplitude is just how far halfway between the maximum and the minimum. The distance is halfway between the max and min. So we can prove we're correct because It's 1 to get up there, and it's 1 to get down here. So if our amplitude is 1, this should meet at the same spot, right? So if I follow this up 1, I get to this line. If I follow this down 1, I get to this line, and they meet at the same spot. So the amplitude is 1. The domain. The domain of a sine function, what I tell you it does, unless I restrict the domain. What does the graph do? Just keeps doing the same graph over and over and over forever, right? So unless the domain is restricted, the domain of a sine function is XER. And remember, this is a basic sine function. This isn't a sine function that's transformed at all. This is just a basic sine function. What was the y-intercept of this sine function up here? Where did it cross the y-axis? 0. Sine functions, unless they're transformed at all, always go through 0, 0. Okay? So the y-intercept is 0, 0. What did we say the period of this sine function was? How long did it take till it repeated itself? 2 pi or 360 degrees. The range of sinusoidal graphs or cosine graphs, so a sine graph or a cosine graph, the range is always between a maximum and a minimum value. Okay? So your range will always look like this. Y such that my minimum value is less than or equal to y is less than or equal to my maximum, YER. Or if it's an interval notation, it's just going to be square bracket minimum, comma, maximum, square bracket. It will always be represented like that if it's a cos or a sine graph. It doesn't matter which one it is. So we need to find our minimum and our maximum, and then it's all the values in between, right? Because the graph goes like this, correct? So it's going to hit a highest spot, it's going to hit a lowest spot, and then there's going to be graph in between it, correct? So your range is between this value and this value, or between this value and this value if it's stretched by a vertical stretch, okay? So what's my minimum value of this graph? What did we find it goes to? Just a basic sine graph. How far did I go down to? -1. And how far did I go up to? +1. So this particular graph's range is y such that -1 is less than or equal to y is less than or equal to +1, YER. Or in interval notation, it's just -1, +1, square bracket. And please, you guys, make sure you read your question thoroughly. If it says the range is round bracket -1 to +1 with round brackets, people read that as a point, okay? Watch yourselves. It's really only that people fall to interval notation if they're both not equal to, so they're both round brackets, because then it really does look like a point, right? -1, comma 1 in round brackets looks like the point -1 and 1. But if it says range or domain in front of it, then it's not a point, it's the range or domain. So make sure you read your questions thoroughly. They don't put any extra words on your diploma than what you need. So if there's a word there, it's there for a reason. Okay? And the intercepts of this sine graph happens every how many? So 0, then pi, then 2 pi, then it's going to happen at 3 pi, then 4 pi, then 5 pi, then 6 pi, then 7 pi, then 8 pi. So it happens every what? 0, and then pi, then 2 pi, then 3 pi, then 4 pi. How many happens every pi or every 180, right? If you look at your unit circle, it does it with even the degrees. Look, it's at 0 and 0. Whenever the sign is at 0, it's at the x-axis, correct? So it's at 0 degrees, then 180 degrees, then back 360, then it's just going to keep happening, right? So it's happening every 180 or pi. So you can list that like this. 0, let's go 0, then pi, then 2 pi, then 3 pi, etc., right? But that's not how they're going to write it. They're going to write it in a general form. Okay, in a general form. We did general form already with a different unit. But if we want to do this in general form, what we're going to do is you'd say this. You're going to start off with your smallest value, which is 0. And then you're going to go plus or minus pi n NEI. We've already done this before, right? So what does this mean? This means I start off at 0, and every pi +1 or -1 or +2 or -2, it's going to happen, right? That's where my x-intercepts are going to be. So x equals this. That's where my x-intercepts are. However, 0 looks ridiculous. 0 plus or minus pi n. If it's a 0, that's your very first term, you just don't write it. So you're not, that's not wrong, but that's not how they're going to write it on the diploma. They're not going to write this minus either. They used to write plus or minus and then go an n. They used to do this. They used to go plus or minus and then go like this with an n and say natural numbers. But no longer do they do that. So they don't do it like that. They do it like this. 0 plus pi n, nei. And then the I, instead of the n, takes into effect integers, so positives and negatives. So then they don't have to put this negative sign here. Because if I put a plus 1 in front of here, it's pi. If I put a negative 1 in for the n, it's negative pi. So that's how they adapted it instead of using the n. My point is that they're not going to write this 0. They're just going to write this. Plus pi n, nei. They're just not going to write the 0. They're not even going to write the plus. They're just going to write pi n when it starts at a 0. Now I could also write this as 180 degrees n, nei. Which one's correct? Well, depends on which one they have there, or depends on which domain they choose. Do they choose pi, or do they choose degrees, or do they choose radians? So instead of -2 this, I want you to go change your calculator to degree mode now, and change your window to this, -360, 360, and 90, and don't change your y's. Your y's are going to stay the same, right? The y's don't change if it's degrees or radians. The only thing that changes are your x's. So keep your sine x into your calculator, but now change it into degree mode, and change your window to -360, 360, and instead of 90, make it go up by, what did we make it go up by? Pi over 6? What's pi over 6 in degrees? 30. So -360, 360, and 30. Did we go to -360 on ours? Where did we start at? Where did we start at on ours? For our x, what did we start at? 0. So if we want to get that exact same graph, instead of 360, make it be a 0. So your x minimum would be 0. Your x maximum would be 360 instead of 2 pi because it's the same. And 30 instead of pi over 6 because that's the same. And make sure it's in degree mode. You should get the exact same graph as you got last time. 0 to 360. If you did -360 to 360, you're just going to get double it, right? Now, if you go to put your equation into your y equals and you look at your graph and it just looks crazy, it's probably because you're in the wrong mode. Okay? You probably have your calculator in the wrong mode. Now, so now we're going to do it for cos. You're going to have to change your window back to the way it was. Ignoring this window. Make your window go from -1 to 1, 0 to 2 pi. These are going up by 0.25. These are going up by pi over 6. Now, you guys, please remember this. The x-axis is in radian mode. Your calculator needs to be in radian mode, at the very least. Okay? Type cos x into your calculator. Now, some people are like, there's this little theta button. I can't get that to show up. Look at the little, I think some people do alpha something to get their x. I didn't realize that till like last year that people are doing that. There's an xt theta n button. It's like below mode. That's the x button. If you want to just get x quickly instead of alpha, whatever the heck gets you x, because I don't even know what it is. The xt theta n below mode is just the x button. If you see there's a little theta there too, it's just showing you that it represents any type of variable that you're filling in. So if the variable here is theta or x or t or n, you're still just going to press that button. Okay, that's all the button is. So if you're alphaing something to get you x, that's fine. But if you just press the xt theta n below mode, it just gets you the x. Okay, so I don't know. Some people have learned it that way. I don't know. Okay, now you don't even need to go onto your calculator. We can go right to our unit circle. Now in this case, cos is the x values, correct? So now I'm going to plot just the big ones. I'm just going to plot the ones around the edge even, or in this case, I'm going to plot the 60s instead of the 30s because the 60s this time are going to get me the halves, right? If you look at 60, it gets me a half. Last time 30 got me a half because I was looking at the y's. This time I'm looking at the x's. So anyways, I'm going to get 0. What's at 0? What's my x? 1 on the unit circle. It's 0 and 1, right? So last time, remember, it was 0, 0, where we started with sine. With cos, we started 0 and 1. And then we have pi over 6, and then we'd have 2 pi over 6, which is actually pi over 3. So at pi over 3, we're at a half. Because at pi over 3, we're at a half. It's the x value, right? And then at 90, at pi over 2, we're at 0, because the x value is 0. So this would be pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, so 2 pi over 3, 5 pi over 6. So then at 5 pi over 6, we're at a half again. Nope, sorry, that's a lie. 2 pi over 3, we're at negative a half. Then at pi, we go to pi, we're at negative 1, because the x value is negative 1. And then if we want, we can go, okay, at 4 pi over 3, we're at negative 0.5. So this is 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, which is 4 pi over 3. We're back at negative 0.5. At 3 pi over 2, we're back at our x value being 0. At 2 pi, we're back at it being 1. So it looks like this. Another way to calculate your period is if you go from a max to a max. After that, you're going to start repeating yourself again, right? If I go from a max all the way back to a max, then after that, I'm going to go back and do a max, and then back and do a max. So from max to max is the length of a period. From min to min is the length of a period. If you go from the middle past a max, past a min, back to that same value, that's the period. So you can find it a few different ways. So the period of a cos graph that hasn't been transformed or stretched is 0 to 2 pi as well, because I'm going from a max to a max. I would say from an ovary to an ovary. Do you get it? Is a period. I know an ovary to an ovary doesn't get a period, but it's funny. Anyways, so I should teach Bio 30. Period. See? So you'll remember that. You watch yourself. Okay. So the period of this graph is 2 pi again, or 360 degrees. So what's the great thing about sine and cosine graphs? If they haven't been transformed at all, their period is 360 degrees, or 2 pi. They're often going to be transformed, so it's not going to stick that way, but we'll deal with it when it comes. Okay? What's the amplitude of this graph? How far is it halfway from the distance from the top to the bottom? What's the distance from the max to the min? The distance of 2. What's halfway of that? 1. So the amplitude is 1. Or remember, we could go absolute value of max minus min divided by 2. So it would be absolute value of 1 minus a minus 1 over 2, which is the absolute value of 2 over 2, which is 2 over 2, which is 1. So you can do that, or you can literally go, how far is it from min to max? 2? Okay, absolute's 1. It's half of that. Or you can fill into that formula and memorize the formula. It's not given to you. Amplitude is always positive. So if you say negative amplitude when I give you an equation, which is going to make you think you should, stop yourself. It can't happen. Amplitude's a distance. The domain of this graph is XER, unless I restrict it. Or in interval notation, that's negative infinity to positive infinity. What's the y-intercept of this graph? Where does it cross the y-axis? 1. 0 and 1. So the y-intercept of a sine graph was 0, 0. The y-intercept of a cos graph is 0, 1. The range, what's the maximum I go to? 1. What's the minimum I go to? Negative 1. So I can either do it in set notation. So -1 is less than y, or equal to y is less than or equal to 1, y-er. Or I can do interval notation, which is way easier. However, you can't bank on just interval notation because it might not be in that as an option on your diploma, right? We need to know how to do both. And the intercepts, what's the very first positive intercept that I cross? X-intercept. Remember, theta is just another way of saying is in X. Remember on that button, there's a theta, there's an X, there's a T, there's an N. It could be a smiley face for all it matters. That's X. So these are the X-intercepts. What's the very smallest positive X-intercept on that graph? Where is it cross at? Pi over 2, correct? Now, some people may not spot how often it repeats itself, but look, it crosses the X at pi over 2 when X is 0, and it crosses the X at 3 pi over 2 when X is 0. How far is that a distance of? 180, which is what in radians? Pi, 180 in pi. So it happens every pi as well, just like the other one. So it's going to be pi over 2 plus pi n e I. We keep the pi over 2 this time because it's not a 0. Like last time it was a 0, so we just dropped it off because 0 plus something seems silly. I mean, you can just write it. It's going to be pi over 2 plus pi n because it happens every 180. Or if this wasn't in radian mode, I would go pi over 2 is 90 degrees plus 180 degrees n NEI. Does that make sense? We do tan graphs last, so it's not, tan graphs look crazy. Tan graphs have like amplitudes and it does like a little weird thing like this and they just keep going on forever. And then if they reflect the other, they go like this. What is it? There's little asymptotes in there. Why would there be asymptotes in tan graphs? Tans are what divided by what? Sine divided by cos, right? Sine divided by cos? So if I look at 90 here, sine divided by cos is y divided by x. What's 1 divided by 0? Undefined. And what happens when you have something undefined? You get an asymptote. So that's why tan graphs have asymptotes. And if you haven't spotted this yet, at 45, tans are either 1 or -1 at 45. Because at this 45, it's going to be root 2 over 2 divided by root 2 over 2. What's root 2 over 2 divided by root 2 over 2? 1. Fancy looking horrible fraction, but it's just 1. This 45, it would be root 2 over 2 divided by negative root 2 over 2, which is -1. But tan's negative in this quadrant, so it makes sense. This would be negative root 2 over 2 divided by negative root 2 over 2, which is positive 1. Tan's positive here, so that makes sense. And then this would be negative root 2 over 2 divided by root 2 over 2, which is -1. So you have to spot things with tans and coses. Honestly, seeing them in graph form will make more sense for the beginning stuff rather than it just being told to you and you memorize it.